Okay. Welcome to video class number 3. In this video, we are going to study about the effects of feedback. You might be wondering why you need to study the effects of feedback in a control system. Because in the last class, I have explained about the how to find out the transfer function of a closed loop system. So here is a closed loop system for you as shown. We have studied. I'll just give you a recap of the closed loop system. And we know why we prefer closed loop system over open loop system because of its numerous advantages over open loop system. Okay, the only dominant problem that we saw is the stability problem with regard to closed loop system, and that also I said that it's due to the feedback. But even if there is a problem like that, there are many advantages which of a closed loop system which actually makes the system better than an open loop system. But and at some places where the measurements are very critical, we will be forced to use open loop system where we cannot measure the parameter to be controlled. It's so we will be forced to use the open loop system. Now, this is a closed loop system with you now you know the terminologies of this, and this block diagram is totally shown in the Laplace transformed. It's not in the time domain; it is in the S domain. Okay, so you have the input R of S, which we call as the set point, right? And there is a summing point, and unto this summing point the fed back signal it will be compared to this R of S. Okay, and this signal and this we call as the error signal, and the error coming is usually denoted by capital E of S. It's equivalent to E of t, small letter E of t. So based on this error signal, this controller or the controller and the process, the total gain will be represented by G of S, and we call this as the forward path gain, right? And this is the feedback path where we will be taking some of the output, and that will be determined by this H of S. So that this output, a part of output into H of S, will give you a particular input, and we call that as B of S, right? These are the terms that we have already studied. Now, what makes this, so this forms a closed loop system. Now, as I told you earlier, if you hide this feedback, then it's simply a open loop system. So actually this feedback gives this closed loop system a more advantage, even though there is a drawback of stability. And I told you that there are many means by which you can make an unstable system to a stable system. So we don't have to worry too much about that. But because of the presence of this feedback, there are various effects which you have already learned in your electronic circuits classes when you dealt with feedback amplifiers. The effects of feedback, both for positive and negative. There are good effects as well as bad effects, and we will be studying some of the effects of feedback. And those effects are the really, since it is this feedback is a part of a closed loop system, you can also consider that as the effects in a closed loop system. And if we will be talking more many advantages of that. All those advantages of the feedback can be considered as the advantages of a closed loop system, because closed loop system uh, closed loop system sorry it's the feedback which makes the closed loop system better than a open loop system or special. Now this diagram is showing a what type of feedback. This is a negative feedback system, and we will be using throughout the course we'll be using this closed loop system, or this is said to be the basic closed loop system. And what is a transfer function? A general transfer function can be considered as the output's Laplace transform to the input Laplace transform, that is C of S to R of S, is given by Gs divided by 1 plus. Do remember, if it is a negative feedback, this will be 1 plus Gs Hs. Okay. Okay, now let's say the number one effect, that is the effect of feedback on gain. Okay, now look at this block diagram. As I told you, this is the most generalized block diagram of a closed loop system. So you can put this in a block diagram, right? I have told you earlier in a video that there are three types of modeling. That is, one is a mathematical modeling, other one is a block diagram modeling. So this is just a glimpse of that. So you can convert this into a single block diagram like this, right? Right? And this block can be, the input is R of S, the output is Z of S, and you can replace this by this. Actually, this block always the block represents its type of transfer function. So this is actually the transfer function between, okay, G of S is the transfer function along the forward path, while H of S is the function along the feedback path. So we have already seen the transfer function as G of S into, G of S divided by 1 plus GSHS. Okay, so that means you can write this E of S as this into RS. Okay, this is actually RS into RS times this much, right? So RS times this much. How will you represent that in a block diagram? So you can simply represent this as a block, that is GSHS. So this block can be represented as GS by 1 plus GSHS. Okay, so in a sense you can say that this one GSHS can also represents the gain of the system. Okay, gain of the system, right? Now what will happen to the gain of the system by the introduction of feedback? Now here you have considered a negative feedback. Okay, now then 1 plus, so what happens when this gain of the system, as the gain of system increases? Now from this we can see that the gain of the system, so this can represent the gain of a system. Now this gain of a system depends on the, what happens when 1 plus GSHS can be greater than 1 or it can be less than 1, right? Now if this denominator is less than 1, we'll say that the overall gain increases, while if this denominator is greater than 1, then the gain decreases. So at this point the overall gain decreases, while in this point the overall gain increases, right? Do you understand why it is? Because 1 plus GS, if it is less than 1, then since it is in denominator, the overall gain increases. So this is the impact of this. Now that means this what is the, why this 1 plus GS, how this 1 plus GS came into this term? It is due to the feedback. No, imagine that your feedback H of S is 0. What will happen? When H of S is 0, it is simply G of S. So it is because of the presence of H of S, this term has come into the play, right? So this term can be greater than 1 or less than 1. Now next question is how this varies. Now we know that 1 plus GSHS is a function of S. Now what is S? I have taught you in signals and system that S is defined as sigma plus j omega or in an electrical system we usually take S is equal to j omega. So what is this omega? Omega is the frequency. So as the frequency of the input increases, okay, right, 1 plus GSHS has an impact. Okay, so that means this 1 plus GSHS varies according to frequency. Okay, now we cannot say that whether it will increase or decrease. It all depends on the value of this GS and how this G is related to S. Okay, we just need to know the function, the type of the function. Okay, anyway, we can say one thing: as frequency varies, what will vary? 1 plus GSHS varies. Now, this can be varied in such a way that 1 plus GS can be greater than 1 or less than 1, right? Now, if it is greater than 1, then obviously, as this shows, the gain decreases, and if it is less than 1, the gain increases. Okay? So, this is the impact of feedback. Okay, so this is the impact of feedback, and what happens is, see, this is a negative feedback system. So you can just say the negative feedback system, what happens is 1 plus, this is 1 plus GSHS, so it has to be always greater than 1, right? So in a negative feedback system, gain decreases, right? While what happens in a positive feedback system? Now in a positive feedback system, this becomes 1 minus GSHS. So what's the impact on that? When it is 1 minus GS, that has to be the overall, that 1 plus GS will become less than 1, which increases the gain. Okay, hope you understood the difference between these two feedbacks. So these are the two effects that a system can have on gain due to this feedback. So since closed loop system is having a feedback, this particular nature can be visible in a closed loop system, but you cannot find such an impact in an open loop system. Okay. Okay, so the impact of this negative feedback you might have studied in your op-amp class. In an op-amp, you might have seen something like this. Say plus, okay, grounded. You have an input, something like this, and you will call this resistance as RF. And this is a negative feedback. Why? What is the reason? If it is an open loop system, then this is having a the nature of an op-amp is, an ideal op-amp is, the gain is infinity. So what will happen to a system where gain is infinity? When the gain is infinity, what happens is a slight change in the input will make this output saturate. Okay, you have studied in your op-amp class. So the problem with this is high gain. So as to reduce the gain, you give a negative feedback in the form of this RF. So thereby reducing the gain. Okay, that's what actually taking place in an op-amp. And if there would have been no RF, then that op-amp cannot work as an inverting amplifier or a non-inverting amplifier. Many of the applications you cannot use without this feedback, without this negative feedback. Okay. Now, similarly, positive feedback is also having its own advantage. When it comes to generation of signals, we usually employ positive feedback, while that is not good in a control system point of view, because that's the problem with the closed loop system, because it is the positive feedback which actually makes the system oscillate, and which is not desirable as far as a control system is concerned. Okay. Okay. Now one more point is, see, this 1 plus GSH, I've explained the limits of this 1 plus GSHS, or when 1 plus GSHS becomes less than 1, the gain increases, greater than 1, gain decreases. So in another sense also you can say that this is also dependent on the frequency, right? So as the frequency can, so based on the frequency, this value can be greater than 1 or less than 1. So you can sum up this in this statement. the statement. I'll read it for you. A feedback could increase the system gain in one frequency range. That means, say, this 1 plus GSHS is a function of frequency, and you have a wide range of frequencies starting from 0 to infinite hertz. So for some range of frequency, this value will be less than 1, and for some range of frequency, it can be greater than 1. So that's it. That's what it is written. A feedback could increase the system gain in one frequency range while decrease in another range. Okay, so it is actually the control of this gain which actually makes a system stable or an unstable. Okay, we'll see it in detail later. The second impact is, or the effect is, stability of a system. I have explained a bit about stability in the previous video, as well as in our previous classes in signals and systems. So you're aware of this term stability. Now, coming to this stability, you know the transfer function is, I'm rewriting it again for you. For a negative feedback system, this is 1 plus GSHS, right? So this is the general equation for a closed loop system. Now what will happen is when this 1 plus GS becomes equal to 0? 1 plus GS equals to 0 means, so always keep this in mind, this block diagram. That is, you have an R of S, and this is your transfer function, and this is your C of S. So every time you have a value for C of S based on this transfer function, right? This transfer function multiplied by R of S will give you a C of S. Now sometimes there can be a situation, so as I told you just before, that this is a frequency dependent term. So as frequency varies, this 1 plus GSHS, the value of 1 plus GSHS changes. So it can be, in the previous section I told you, it can be greater than 1 or it can be less than 1. It all depends on the frequency. Now, at a particular frequency, what happens is 1 plus GS can be 0, right? Now, when 1 plus GS becomes 0, what will happen to the transfer function? Your transfer function becomes infinity. So what will be your output? Output will be R of S into an infinite value. So this is an undefined value, or you will say that the output gets saturated, right? So this is actually instability. This is instability, okay? Saturated. Okay, now, so the thing of what we need to consider is, you should make sure that 1 plus GSHS should never be 0. Okay. Now in a positive feedback, actually, okay, I'll explain. So when you 1 plus GSHS equal to 0, from this, what you can write is GSHS is equal to minus 1, right? Okay, so this is the condition for instability, or you might have, you can recollect from the, when you studied about the oscillation, there is a Barkhausen criterion where you can see that this, you might have come across a term something similar to this. So that is an advantage in the case of an oscillator. But as far as a control system is concerned, this condition should not be met in a control system, because this will make the system unstable and that will make the system oscillate. Okay, so the problem with this, one of the major problem of this control closed loop system is the stability. But as I mentioned, this is with regard to a particular frequency, right? Only at a particular frequency only this 1 plus GSHS becomes equal to 0. So if we can have a mechanism by which you can restrict those frequency and suitably selecting this HFS, right? It is the HFS which actually changes the whole scenario. So if you can able to suitably select this HFS, you can make sure that this GFS HFS will never become minus 1. If you can ensure that, you can also ensure the system to be always stable. So that's why I told you, even if it is a drawback, this always it has an upper hand when compared to an open loop system, because it has numerous advantages. And not only that, even the instability problem can also be solved by using proper feedback. Okay, so for example, you might have seen such a block diagram when you might have studied positive feedback amplifiers. Okay, if you're not remembering, it's okay. I'll just explain. So this is similar to the closed loop system that we have already drawn. So suppose, imagine that this selected h of s arrive at this condition, g of s h of s equal to -1. So what will happen? The system will oscillate, or it will be moving to instability. So it is going to be undefined. Okay. Now, to prevent that, what I do is, so instead of that, I'm also adding one more feedback. See, okay, so I'm adding one more feedback, something like this. Okay, I'm adding a feedback, something like this. Okay, so what will happen? So first of all, if you don't have this, the equation will be g by 1 plus gh. Now, by the introduction of this feedback, this equation becomes 1 by 1 plus gh plus gf, right? And due to the introduction of this gf, so this is just an example, right? So g by 1 plus gh, it is so selected that this becomes uh, an unstable system, because that has met gs hs equal to -1. Upon introduction of another feedback network, the overall uh, forward gain into feed forward becomes, will not be, it will get disturbed from this condition. And if it gets disturbed from this condition, then you can pretty make sure that the system becomes unstable. So that's why I told you, even if a control system is unstable, there are many mechanisms by which you can make that system stable. Something like introducing a feedback network, or something like introducing a, in terms of electrical system, we will say something like introducing a capacitance, introducing an inductor. Okay, all those things I will explain when during the course, so we'll understand that. Okay, so you can have a statement of this: a feedback can improve stability, and in addition to that, you should add one more statement: or it be harmful. Okay, it has got two effects. It can either improve stability, that's what I explained here, and it can be harmful, that's what I explained by these two, right? It can be harmful to the stability, if the feedback is not properly applied. Not properly applied. What's the meaning of that? Properly applied means without looking at this condition. If you connect a feedback, and if you are not aware of these conditions, sometimes this condition may be met, and that will make the system unstable. So if the feedback is proper, so what's the thread of this under this topic is, you need to, there is no problem in having a feedback, but when you select a feedback, it has to be properly placed and properly applied. Otherwise, that particular feedback can give an harmful effect to your control system in terms of stability. Okay, now the next point is, next effect is the sensitivity. Okay, again I am considering a closed loop system. When I say closed loop system, you should not say that, oh, you don't have a feedback, then how can you call this as a closed loop? It is this closed loop system, okay, I'm considering, and I have already found out the transfer function, And I told you that this can be represented by a block diagram like this. So this is actually a block diagram of a closed loop system. So when you see such a figure, you should have this picture in your mind. That means you should consider this as a, even though there is no feedback, don't think that there is no feedback. So how can you call this as a closed loop system? It is a closed loop system because this is the transfer function of a system. I am considering this as a full block. Okay. So, and from here onwards, I will be using this only. So you need to understand this is a closed loop system. Okay. Now, this one is a closed loop system. Now, what is a for a good control system? A good control system. What is the objective of a control system? The control system should make this C of S. This is the output to be controlled. This output must be in control always. Okay, so it is the ability of the system to make it controlled every time. So that means this a good control system should be insensitive. Should be insensitive. Look at, remember this word, insensitive to the parameter variations. Parameter variations. While sensitive to input. Sensitive to input. Okay, two terms. One is it has to be insensitive to the parameter variations. So what is the meaning of that? See, by parameter variation it refers to, you have studied in your aerial basic electronics classes, many of the electronic devices depends on the temperature, right? Even, what to say, even resistance also depends on temperature. So as the temperature increases, these parameters can change. The internal components of this system can change. So that change can affect the output. So as far as possible, in a controlled system point of view, this has to be insensitive. That means it should not respond to that variation so as to ensure a controlled output. But at the same time, you will have to see this figure again. At the same time, it has to be very sensitive to the input, right? Very sensitive to the input. What's the need of that? That is to ensure the output to be always at the set point. So it's a slight variation in the set point will make the, yeah, a slight, or this input, slight variation in this input will make the system uncontrollable. So that requires some amount of looping so that it will regain its original value. So this is the thing. So it has to be very insensitive to the parameter variation. Okay, we'll have an expression of that right now. Okay, so I'm going to introduce a term by which you measure the sensitivity. The sensitivity is represented as S suffix G M. Okay, S suffix G M. And this is actually the sensitivity of gain of the overall system gain, say call this as T, to the variation in G, Okay, so what is the meaning of that is, so I told you that, I mean, system parameter varies. If system parameter varies, that affects the gain, right? This part. Now, and the sensitivity gives you an idea about the sensitivity here. It is defined as, so you can write like this, S suffix G and, okay, now raised to M. It is sensitivity of gain of the overall system gain to the variation in G. Okay, now this is defined as percentage change in T. change in T, that is the overall system gain, divided by the percentage change in G, that is the forward gain. So variation in G means, what is this G? G is the forward gain. As I told you, G is the forward gain. And what is the overall transfer function? Overall transfer function is GS. So it is actually, sensitivity is defined as the change in the transfer function with respect to change in G. Now when system parameter changes, that will badly affect the G. That change, how much that change will affect the overall transfer function of the system, that is given by this term sensitivity, SGN. Okay, now this is percentage change in T. So what is this? You can write an equation like this. So that is the change in overall transfer function. So let that be delta T. How will you write the percentage? That is by T into 100% divided by, what is the percentage change in G? That is, let us call this as change in G is delta G by G into 100. Okay. So what you can do is, this will be delta T by delta G, this 100 and 100 gets cancelled, into G by T. Okay. Now from limiting theorem, applying this limiting theorem, you can convert this into what? This can be viewed as d by what? It is equivalent to taking the derivative of the overall transfer function with respect to dg. Okay, that's the change. See, that's the application of differentiation. That is to find out the change with respect to something. So you are going to find out the rate of change of this transfer function with the change in G, okay, into G by T. Okay, now what you are going to do is, you are actually going to take the derivative of what? G by 1 plus GH. Okay, into, and after taking the derivation, that has to be multiplied by this capital G by T, right? Now what, how will you do, how will you perform this differentiation? This is, you can perform U by V rule, that is U into dV minus V into du by V square. Okay, so hope you know that. Using that U by V form, you can differentiate this, so that this becomes 1 plus GH minus GH by 1 the whole square into G by T. Okay, so this and this get cancelled, so that okay, so the equation becomes 1 by 1 plus GH the whole square into G divided by, what is this T? T is actually, we have already studied it as GS by 1 plus GSHS. Okay, now at times we will be using G and S. We won't be specifying of S. It is obvious that it is a function of S. So this will be G into 1 plus, so instead of T you will be writing, this G into 1 plus GH, right? And this G and G gets cancelled, this 1 plus GH, this get cancelled, so that your sensitivity, okay, of the gain of the overall transfer function, overall, that is SM to G, is given as 1 by 1 plus GH, right? So now what happens? Now coming to this equation, so what is the requirement of a control system? This sensitivity has to be very much less in the system parameter variation, right? Now I told you that when system parameter varies, that affects G. Okay, So if the system parameter varies, then that affects G, and the effect of that G will definitely affect the overall transfer function. So how to reduce it? By using this term, you can come to a conclusion that if what happens if GH is increased? What happens when GS is increased? GS is increased means you can reduce this SGM, and that's what we require, right? As for the control system, we require this. Now, how can you ensure GH is increased when okay, even if there is a gain, a slight gain increase, what happens to this? GH increases, right? And it is because of the effect of what? Increased. If GH is increased, if GH is very high, you can make sure that the system sensitivity towards the parameter variations will be less. Okay, so that the system should remain stable even if there is a slight change in the inside parameters. So what is actually the reason behind this? This is due to what will happen if H is equal to 0. So sensitivity remains 1. It will be high, right? So this will reduce the sensitivity, right? At the same time, so that means the output is not going to get affected. Okay, right? So system function is minimized. The system function is minimized when GH is increased. GH is increased. Now, how is it made increased? It is made increased by the presence of this H. Okay, so that is the impact of feedback on sensitivity. Okay, next is the effect of feedback on external disturbance. So I'm considering again a closed loop path and a closed loop system. This is the so just imagine that this is actually, you know that this is G by 1 plus GH. That is your, so what is your Y? Y will be, or Y will be this times, okay, call this as C. So C will be equal to G times into R. Let it be R. Okay, we know that. Now imagine that you have a, in this say, an external disturbance, let us call that as a noise, N comes along somewhere or other, it comes into this block. So external noise is something which can occur at any time. That is at any time without any sort of notice. So that is unexpected. That's why we categorize that as a random signal. It is unexpected. It cannot be predicted. So imagine that a noise disturbance comes along with this path and it gets induced. So what will happen to the output equation? This output equation now becomes y is equal to C into N into R by 1 plus GH. Okay. Now just imagine, had it been a open loop system, I'm just comparing this, R, C, G, and an external disturbance. So what will be your equation for C? C will be, it is C. C will be equal to G times N, right? G into N. Am I right? Okay. Now let us compare these two equations. The output is, which among this, which output is worst affected? The whole of N comes at the output, right? Now what about this? Even though you can find a term, what about this? N by 1 plus GH will only come at the output. That means, will it be reduced or increased? Yes, it will be increased. It will be reduced, right? N divided by something. So the effectively the noise or the external disturbance gets, the effect of that noise gets reduced due to the feedback. while without feedback the whole of the noise will come at the output. Have you understood this? So these are the effects of feedback, and I have already mentioned in the last video there are, about 6 or 7 points regarding, reduced effects of non-linearities and all those things. You can read from the textbook. You will get a lot of points. But these are the effects of. Sometimes questions can be asked and explain the various effects of in detail. So you need to give the necessary equations and relations to prove that. Okay, so hope you understood this topic. Okay.